Okay, section 9.4 is graphing parabolas. We kind of did graphing parabolas a little bit when we were solving equations by factoring, but this is the first thing we're going to learn to graph in our conics section. So this is a type of conic. And when we graph quadratic functions, so things that have something squared, the graphs are called parabolas. So a lot of us know this already. And there's many different ways to graph a parabola, and we're only going to cover a few of them. Normally, if we were with each other, we would be learning a lot more, but we're really just going to kind of skim the surface so you have some sort of basic foundation on how to graph a parabola. So before we get into graphing them, I want to talk about the different parts of a parabola. So remember, a parabola is this U-shaped graph, and all parabolas have a vertex and an axis of symmetry. Okay, so here's our vertex, and here it's pointing at my axis of symmetry. Okay, so your vertex is your highest or lowest point of your parabola, depending on if your parabola is an upward U or an upside down U. So in this case, this is an upward U, so my vertex is the lowest point of that U. And then our axis of symmetry is that vertical line. Sometimes it could be horizontal if you see a parabola laying on its side, but in this case, a vertical line, and it cuts that parabola in half, meaning if I were to reflect this part of the parabola to the other side, so kind of lift it off the page and flip it over onto the other side into the second quadrant, it should land exactly where this part of the parabola is. Okay, so really it's just cutting it in perfect symmetry. Okay, it's going to be in half. Let me make this bigger. I can't erase it. Okay. So it also means that each point is the same distance from the vertex on the opposite side. So this point right here is to the right one and up one, and then over here it's the complete opposite, so it's to the left one, up one. This point over here to the right two, up four, and this one is to the left two and up four. Okay, notice that they are horizontal of each other, so they will always be horizontal of each other, just opposite, so flipped over the y-axis. Okay, so the axis of symmetry always passes through the vertex. So if you ever want to know where is my line of symmetry, find your vertex, and it's a vertical line through that vertex. Okay, remember, vertical lines are your x equals equation. So it's going to be x equals whatever the x coordinate of your vertex is. So here, my vertex is 0, 0. Well, my x coordinate of the vertex is 0, so my line of symmetry is x equals 0. That's my vertical line. That cuts the parabola in half, that if I folded it over like a sandwich, it would look exactly the same. Okay, like I said, a parabola is a U-shaped graph, and different parts of your quadratic equation determine whether your graph opens up or down, or if it's going left or right. Okay, so for the quadratic equation in standard form, so right here I have ax squared plus bx plus c equals 0. If a is positive, so the number in front of x squared, here's my a. If that is a positive number, your graph, no matter what, is going to point upwards. Notice that in this graph, there's no x-intercepts, so hopefully you're kind of referring back to the previous lesson we had. If there's no x-intercepts and your parabola is kind of floating in midair, and it's not crossing the x-axis, that means your discriminant, so the inside of your radical of your quadratic formula, ends up being a negative number, which means we have two non-real complex solutions in this case. I mean, it doesn't really matter. I just kind of want to bring that back to your memory. And then, in example 2, if a is negative, so the number in front of x squared is negative, that means my graph is going to be pointing downward. So it's going to be an upside down U. Okay, again, then refreshing your memory. If is this discriminant positive or negative without plugging it in? Okay, so hopefully you remember it's crossing the x-axis at 2 spots. That means I have 2 real solutions, which means my discriminant was positive. Again, not a big deal if you remember that or not, but it is kind of a good thing to refresh your memory on. Okay. If your x's and y's are switched, then that's when your parabola becomes sideways. So I know you guys have seen a sideways parabola, and the reason why it looks like that is because in this case, now the y is getting squared and it's set equal to x. So in our previous examples, x was getting squared and it was equal to y. Well, now it's y getting squared and it's equal to x. So when it's flipped like that, I know I'm going to have a parabola on its side, and then A is going to determine which way it's opening. So if A is positive in this one, then it's going to open towards the right. Okay? If A is negative, so the number in front of my variable squared, then it's going to open to the left, towards the negative direction. So same thought process as if it was going up and down. So if it was negative and it was equal to y and x was getting squared, it would go down towards the negatives on the y-axis. Well, now, since the x's and y's are flipped, it's going towards the negatives on the x-axis. Okay, so it's pretty much the same graph. If I turned my screen around and I flipped this graph, it would look the same, and you actually wouldn't really know the difference unless you labeled your axes x and y. Okay, so the first method to graphing a parabola, we've actually learned this before. We won't be learning this again. I'm just going to do one example as a refresher. You actually were tested on this. So when you're graphing a parabola, you have options, and the first one is to find the x and y intercepts. Well, to find the x and y intercepts, I'm going to first change this to y. Remember, f of x is just a fancy way to write y in a function. And I'm going to set my equation equal to 0. So I'm going to make y equal to 0 to find my x-intercepts. So hopefully this kind of looks familiar. You have this equal to 0, and I'm going to solve this by factoring. So I'm going to get x plus 2 and x plus 1. And I'm going to solve for x. So x equals negative 2, x equals negative 1. So these are my two x-intercepts. So I have two real solutions, and they're going to cross the x-axis. So on the x-axis, I'm going to plot negative 2, and I'm going to plot negative 1. And then I want to find the y-intercept. So instead of setting y equal to 0, I need to set x equal to 0. So y equals 0 squared plus 3 times 0 plus 2. Or if you remember the shortcut, my constant is always going to be my y-intercept. So y equals 2. So my y-intercept is 0, 2. So I'm going to plot that. And notice A is positive, so I know that my parabola is going to be facing upward. So I'm going to connect to these 3 points. You always need 3 points when you're drawing a parabola. Oop. And we're going to point our parabola upwards, and then we're done. Okay, so you could totally use that method if this is factorable. You could use the quadratic formula, but it's really hard to graph decimals and irrational numbers. So just keep that in mind. But let's move on to graphing quadratics of the form f of x, or if it makes you feel better, you could write y equals ax squared. So A doesn't only affect whether the parabola opens up or down, it also affects how stretched or narrow your graph is going to be. Okay, So in all of these problems, f of x equals x squared or y equals x squared is our parent function. It's called our base function. So every type of parabola we graph is based off of this graph right here. Okay, so this is your basic quadratic graph. It's the most basic form of our parabola. It's like our OG parabola. Everything starts from this parabola. Okay, and every time we add something different to the x squared, whether it has a number in front of the x squared or I'm adding something to the x squared, it could shift your original graph left, right, up, or down, and it could also make your graph wider or more narrow. Okay, so keep that in mind once we start walking through these different types of parabolas. So let's compare these different types of graphs. So notice all of these have an x squared and some number in front, but nothing's being added to them. So let's see what happens to all of those graphs. Okay, notice that this one in pink right here, that's our OG graph. And notice how the numbers in front of x squared are changing the way the parabola not moves, but expands. So if I multiply by 2, it's getting more narrow. If I multiply by 1/2, it gets wider, 1/3 even wider, 1/4 even wider. Okay, and same thing for here. If I multiply by negative numbers, so a is negative, it's pointing downwards, but it's still expanding the graph or making it more narrow. Okay, so hopefully you're noticing that a, so the number in front of your variable squared, if you take the absolute value of it, the bigger the number gets, the more narrow your number is going to get. Okay, so if I multiply by 2 or negative 2, the absolute value of that would be 2, so I'm multiplying by a bigger number. It's going to stretch out your graph. I'm pulling it thinner, so that's just saying that my y values are increasing by 2, so my graph is actually getting longer. Okay, so if you start multiplying by smaller numbers like fractions, then the wider your graph is going to become. Okay, note that all of these graphs still have the same exact vertex and same exact axis of symmetry. So the x equals 0 is right down the middle of all of those parabolas. And it's the same as your parent function, the x squared graph. So they all share the same vertex. So all A is changing is the direction of your parabola, so whether it's up or down, and it's determining its width. That's it. So that's all A does in your equations. So let's sketch a graph for some of these, for example. So essentially this is our second method, and this is literally just creating a table of values. Okay, so I'm going to be using an XY chart. We need at least 3 points. And know that since nothing's being added here, that's your vertex. So our vertex is 0, 0. So when nothing's being added to these, and it's just something squared, the vertex will always be 0, 0. So I know right away my point's going to be 0, 0. Because if I plug in 0 for x, well, x squared is 0. 0 squared is 0 times negative 4 is 0. So y equals 0. Remember, this is saying y equals negative 4x squared. So I'm going to pick another value. Let's pick 1. Plug it into here. So y equals negative 4 times 1 squared, which is negative 4. Let's choose negative 1. That's also going to be negative 4. And let's choose 2, which would be negative 16. And let's choose negative 2, which will also be negative 16. So I'm going to plot these points. Before I plot, I just want you to think to yourself, which way is this parabola going to be pointing? Well, I know that a, the number in front of x squared, is negative, which equals pointing down. And you'll see that when you plot your points. So I have 0, 0, and I have 1, negative 4, negative 1, negative 4. Notice that these points are lining up. They should be horizontal of each other. And then I have 2 and 16 and negative 2, negative 16. Notice how narrow my graph is. And that's because I'm multiplying by a large number to the x squared. Remember, the larger the number, the more narrow it's going to be. Sorry, this should be a little more curved. Okay, and that's your parabola. Same thing with number 2. Nothing's being added to the x squared. So I know that my vertex is going to be 0, 0. And I'm just going to pick values. I'm going to try to pick values that are going to make the denominator go away. So let's choose 4. So if I plugged it in, I'm going to get 16 times 3/4, which is going to be 12. And I'm going to do the same thing to negative 4, which is also going to get me positive 12. You could do 2. So y equals 3/4 times 2 squared, which is 3/4 times 4. So I'm trying to find numbers that'll cancel out the 4 in the denominator. And that'll be 3. And I'll get the same thing if I plug in negative 2. Okay, I generally like to get 4 other points from the vertex, but if only 3 could fit on the graph, that's fine. But you need 100%, you need at least 3, because 3 points determine a parabola. Okay, so I know that my graph is going to go upwards because 3/4 is positive. So I'm starting at 0, 0, and I have 2, 3, and negative 2, 3, and then we came up with 4, 12, and negative 4, 12. Okay, and then I'm going to connect my points. Sorry, it's a little sloppy, and then we're done. There's my parabola. Okay, now I'm going to start talking about when we're graphing parabolas and something's being now added to our x squared. Okay, again, remember this f of x is really just a y. So again, we already established that a determines whether it's the u is going up or the u is going down, and it's determining the width. Now let's talk about what the k does. Okay, so in this example, they're graphing 2x squared plus 3 and 2x squared minus 4. So 2x squared we call is their basic function, so that's like their base function starting at 0, 0 is their vertex. And notice what happens when we add 3 to that basic function. So here's my base function right here in the dotted line. So if I add 3 to that, notice where the vertex is. The vertex is now at 0, 3, and it was at 0, 0. Notice what happens when I subtract 4 from it. Now it's at 0, negative 4. So think to yourself, okay, what's happening when I add or subtract to these graphs? Well, it's just shifting the graph up or down on the y-axis. Okay, it's just moving the vertex up by that many steps or down by that many steps, whether you're adding to it or you're subtracting. If you're subtracting, obviously we're moving down. If you're adding, you're moving up. Notice that the widths are exactly the same. So even in these graphs, so I have negative x squared plus 4, negative x squared minus 2. So my base graph is negative x squared right here in the dotted blue. Now when I add 4 to that same graph, I'm shifting my vertex up 4 spots. When I subtract 2, I'm shifting that same exact graph 2 spots down. Notice the width is exactly the same. All of the points are still the same distance from each other. In this basic graph, if I want to get to my next point, I go 1 to the right, 1 down. Here, in this purple graph, I should be able to do the same exact thing to get to the next point. So I'm going to go right and then down. I'm ending up still at the same point. Okay, it's just shifting. So this point is at negative 1, 1. My next point should be in the next graph that I have. That point should just be shifted 2 spots down, so it should be at negative 1. I'm sorry, this should be negative 1. 1, negative 1. Whoopsies. 1, negative 1. So if I shift it down 2 more, it should be at 1, negative 3. Let's see, this is at 1, negative 3. Yep. So it's holding the same shape, it's just moving it across the graph. Okay, so in conclusion, if k is positive, so if you're adding to your graph, we shift the graph up. If k is negative, so you're subtracting from your graph, we shift the graph down. Like I said, these graphs still have the same axis of symmetry, and the only thing k changes is where your vertex is located on the y-axis. The width of your graph holds as your graph shifts. Okay? So in this example, the base graph would be 3x squared, which means it's going to be a narrow graph because I'm multiplying by a bigger number. So you could graph 3x squared and then shift it down 2 spots, or you could just plug and chug. So I kind of recommend doing that. That'll be a little bit quicker. So if I plug in x is equal to 0, I'm now going to get negative 2 as my y-intercept, right? This is y equals 3x squared minus 2. Let's say I plug in 1. I'm going to get 3 minus 2, which is 1. So what I'm doing is plugging in for x, any values. I'm just picking any values that I want. Let's pick negative 1. I'm also going to get 1. Let's pick 2. So I get 4 times 3, which is 12, minus 2, that's 10. And I'm going to do negative 2, which is also going to get me 10. Okay, so 0, negative 2 is my vertex. 1, 1, and negative 1, 1 is those 2 points. And then I have 2, 10. So 2, 10 right here, and negative 2, 10 up here. Notice how narrow my graph is. That's because my distance between my y's is getting bigger, so the more narrow my graph is becoming. Okay, and then I'm going to curve up. And there's my parabola. Okay, and then lastly, graphing functions of the form a times the quantity of x minus h squared plus k. Okay, this is very important. This is called vertex form. Now, when your graph is in this form, remember f of x is also y, it's actually quite simple because it's giving you your vertex right away. Okay, that's why it's called vertex form, because h right here is giving you the x value of your vertex, your x coordinate, and k is giving you your y coordinate of your vertex. So let's go back to this. This is k, and this is giving me the the y coordinate of my vertex. Well, notice where my vertex is. 0, negative 2. There's my y coordinate. Okay, so this is going to help me out a lot. So h and k are going to give you your x and your y coordinates of your vertex. So for example, I have this function, here's my a, here's my h, and here's my k. Well, it needs to be x minus h, and your x coordinate's always going to be the opposite. So don't think that your x is going to be -4. Your x is actually equal to +4, but this is always going to be true to the sign. So this is going to be +2. Okay, in this example, this should be x minus. So this is, think about how I can make this a subtraction problem. This is actually x minus -3, right? Two negatives create a positive. So h is actually -3. So it's always going to be the opposite when it's with the x. Okay, so it's going to be opposite, so -3. And then my y, again, that one just stays the same. That's going to be -1. Okay, before we get into actually graphing using the vertex form, let's just talk about how h affects your graph. Okay, so let's look at these graphs. We're starting with our base function as 2x squared. If you added to your x or you subtracted from your x, notice what it's doing. It's kind of doing the opposite of what you would think. So subtracting from x, this is actually +3. So it's shifting your graph 3 to the right. So again, think opposite. Over here, the 4, this is actually -4. It's shifting your graph 4 to the left. So the vertex is staying on the x-axis, but it's kind of moving along the x-axis, however many is inside of the parentheses with that x. So it's either moving 3 to the right or moving 4 to the left. Okay, so our conclusion is if h is positive, which I know it doesn't look like it is, but in this case, h is positive. So if it's being subtracted from the x, we shift right. So think opposite. So if it's negative, I'm moving to the right. If h is negative, okay, technically it's being added in there, we shift the graph to the left. Okay, like I said, all of the graphs have the same width. Oops, spelled that wrong. So h shifts our graphs left and right, but the graphs do not move up and down. So let's do a recap. Your a, no matter what form we're in, affects your width. The larger a is, the more narrow your graph is. It also affects up or down. Okay, your h, so this number inside with the x, always shifts it left or right, opposite of what you would think. Okay, so in the standard form, this would be shifting it to the right. Okay, and then your k shifts your graph up or down along the y-axis. And then finally, h comma k, that's going to give us our starting point. That's our vertex. Now, I think using vertex form is a little bit easier than having to just always use an XY chart. So let's look at this first. First of all, I know that this is negative, so I know this is pointing down. And I know my function's getting shifted to the left. Okay, that's good to keep in mind. But also, it's not the biggest deal because I could just figure out what the vertex is. So this is +0. So no, that's my h, that's my k. Well, h comma k is equal to my vertex. So my vertex is equal to -1, so it's always the opposite inside of here, comma 0. So that's where I'm going to start. -1, comma 0. Now, instead of plugging and chugging to find all these different types of points, what I'm going to do is just pick a few that are directly after the x value of your vertex. Okay, so you could either go -2, -3, or you could do 0, 1. You see what I'm saying? Just going directly in order on either side of -1. I'm just going to do 0 and 1. so 0. So I'm going to plug in 0 to this function for x. So y equals negative 2 times 0 plus 1 squared. So negative 2 times 1 squared, which equals negative 2. So there's 1 point, and then I'm going to do the next number, which is 1. I'm going to plug that in for x. So negative 2 times 2 squared, which is 4 times negative 2, so I get negative 8. Okay, I'm going to stop right there, and I'm going to plot those 2 points. So 0, negative 2, and 1, negative 8. Okay, sorry, these numbers are throwing me off to what number is which, or what line is which. So this is why it's good to know if your graph is supposed to open up or down, because if your points aren't flying where they should be, where it would be pointing down when it should be a pointing down parabola, then you're doing something wrong. Okay, so right now I'm going to stop here and I'm going to find the axis of symmetry. Remember, your axis of symmetry goes through your vertex. So that's right here, right? So here's my axis of symmetry. This point is negative 1, 0. And your axis of symmetry is always equal to your x coordinate. So x equals negative 1. So what you're going to do is you're going to plot points horizontal from your other points, but it's got to be symmetrical. So see how this point right here is 1 spot away from your axis of symmetry? Well, on the negative 2 on the other side, it needs to be 1 away from your axis of symmetry. So I'm going to do the other symmetrical points in a different color so you could see. So now this is negative 3, negative 2. Here I am 1, 2 spots away from the line of symmetry, so I'm going to go 1, 2 spots away from the line of symmetry, creating that. It should still be a horizontal line between your 2 points of symmetry. Okay, now you can kind of see what my parabola is going to look like, so I'm going to connect these. And there's my parabola. Okay, again, that's my vertex. This is my axis of symmetry. You don't have to label these. So all I had to do was find these 2 points and then graph the symmetrical points to them. Much easier than plugging and chugging. Okay? So I'm going to do the same process here with number 2. So my vertex, here's my H, here's my K. So my vertex is equal to, it's the opposite, so for H, so this is positive 4, comma 0. And I'm just going to pick my 2 points before I start plotting everything. Just do numbers consecutive of your x value of your vertex. So I'm either going to do 5, 6, or I'm going to do 3, 2. I'm just going to do 3, 2. So I'm going to plug in 3 to my original function and figure out my y value. So y equals 1/3 of 3 minus 4 squared. So negative 1 squared, so I get 1/3. And then I'm going to plug in 2. 2 minus 4 squared. So I get negative 2 squared, so I get 4/3. Okay, now it's not ideal to be graphing fractions. If you wanted to, you don't have to pick consecutive points. You could pick points that you know would get you values that would eliminate your 1/3, but we could just deal with what we have. So I'm going to plot 4, 0, my graph should be pointing upwards, so make sure your points are corresponding to that. So I have 3 1/3. So 3 1/3 will be somewhere over here. And then I have 2 4/3. So 2 and then 4/3 is 1 1/3, so somewhere right here. And then I'm going to create my line of symmetry. Remember, it goes through the vertex. This is x equals 4. And I'm going to plot those symmetrical points. So this is to the left one, so I'm going to go to the right one and match it at 1/3. And then to the right 2 and match it at 4/3. Okay, and then let me do it in a different color. Connect your points. And we got happy parabola. Okay, number 3. If it makes you feel better, you can make that your y. Here's my h. Here's my k. Now I actually do have a k, so my vertex is 3, 1. And let's find some x, y values. I'm going to pick 4 and 5. So I'm going to plug in 4 right here. So 4 minus 3, that's 1. 1 squared is 1, so 2 times 1 is 2, plus 1, that's 3. Then I'm going to do 5. So 5 minus 3, that's 2. 2 squared, that's 4. Times 2, that's 8. Plus 1, so I get 9. Okay, so I'm going to plot these 3 points. So 3, 1. And notice A is positive. So I should have a parabola going upwards. Then I have 4, 3 is my next point. And then 5, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to create my axis of symmetry, right? It goes through your vertex. And I'm going to create those opposite lines. So this point is 1 away, so I'm going to go 1 to the left and match that horizontally. And then 2 away from the axis of symmetry, and then I'm going to match this horizontally. Okay, if your symmetrical points aren't horizontal to each other, you're not plotting them correctly. Okay, notice they have to be the same distance away. Okay? Connect your points. There's our parabola. So just alluding to how the h and the k and the a's affect your parabola, my vertex is at 3, 1. Well, notice, look at this. This tells you right away where your graph is shifting. It is shifting 3 to the right and shifting up 1. So if I had my original graph, right, my vertex would have been here, and I'm shifting it 3 to the right and then up 1, there's your new vertex. Okay, so that's how you could kind of use knowing information about your shifts on how to adjust your graph. So if you know your base graph, you could easily just shift it. Or if you need like just a quick sketch, just know that the way that your graph is going to be transforming is good skill to have as well. Now with number 4, your x's and y's are switched. So your y is getting squared and it's set equal to x. Sometimes this will say f of y as well. That just means that that's representing x. So that means that my parabola is going to be on its side, and since my a is negative, that means it's going to be opening towards the negative numbers on the x-axis, so it's opening to the left. And your vertex is going to be a little bit different. So your x and your y is also going to be inverted in your vertex. So instead of being 1, 3, it's going to be 3, 1. And when we're creating our XY chart, I'm going to pick values of y instead of values of x. So I'm going to pick, let's say, I'm not going to go consecutive with the y values just because I want to try to find numbers that will be divisible by 2. So let's say I'm going to choose 3 and 5. So if I plug in 3 for y, 3 minus 1, that's 2. 2 squared, that's 4. 4 times negative 1/2, that's negative 2, so then I get 1. And then 5, so 5 minus 1, that's 4. 4 squared is 16. 16 times negative 1/2 is negative 8, and I get negative 5. Okay, so I'm going to plot these 3 points, so 3, 1, 1, 3, and negative 5, 5. So 3, 1, then I have 1, 3, and then I have negative 5, 5, 2, 3, 5. Okay, so remember your line of symmetry goes through your vertex. Well, here's my vertex right here, so my line of symmetry is going to cut through right down the middle. Now, since it's on my side, my line of symmetry is a horizontal line. Remember, horizontal lines are y equals, so this is actually y equals 1. Not that it really matters that you know that, but it's good to know. And then I'm just going to create symmetrical points. So this point right here is to above my line of symmetry, so I'm going to go to below the line of symmetry, creating a vertical line. And here this is 1, 2, 3, 4 above the line of symmetry, so I'm going to go 1, 2, 3, 4 down below the line of symmetry. Now we can see my parabola starting to open up towards the left, curving around, and there's my parabola. Okay, and that's it essentially for vertex form. I know it's going to take a little bit of practice, but please, if you feel like you're getting stuck on the homework, refer back to my videos. You can also refer to the book. A lot of these examples are from the book, and they show kind of step-by-step processes. And then also, again, feel free to shoot me an email. Use Khan Academy. Some of them use different methods, still using vertex form, but explain it slightly differently. You might like that method better. All in all, if you get stuck, you could always just use plug and chug, pick values of x, find a y, and then plot your points. We're going to talk a little bit more with parabolas next lesson, but this is kind of your first introduction to really graphing these accurately.